This is an excerpt from a conversation with Emil Jacobs, Yuan Lee, and Nathan Lewis, moderated by Andrew Revkin, brought to you by the Chemical Heritage Foundation's annual T.T. Chow Symposium.
I'm not going to introduce all of our speakers. As I said, Nate Lewis is coming to us from California. He'll show up on the screen above, well, kind of where that slide is soon. But what I'm going to do, because it's a good way to get them introduced, is I'm going to ask our moderator, Andy Revkin from the blog .earth and the New York Times, to just jump in right now and introduce the panelists as he goes, because he has an opening question for them that'll tie into your questions. Andy, it's all yours.
Thank you very much. Your questions are great, by the way. I've sorted them a little bit, and there are some that were slightly redundant, so if you don't get to ask one, I think you'll see that all the themes have been addressed. And I'm thrilled to be here this morning to run a conversation on one of the critical components that will determine the sort of the pace and extent of human progress in the century, which is access to energy systems that work for the long haul. In other words, that don't have regrets, too many regrets. And we've been stuck on, back in 1954, a couple of years before I was born, there was a scientist, an essayist named Laureate Lee, wrote this wonderful piece of poetry called Man the Fire Maker, and it has this line that always resonates in my head when I confront our situation right now. And the line is that man's long adventure with knowledge has to a very marked degree been a climb up the heat ladder. And when he talked about the heat ladder, he was talking about the sources of heat, from firewood to charcoal to fossil fuels. The atom in the 1950s was the big one. And even in the 1950s, people weren't thinking about solar technology so much and that kind of thing. But you can see how that works. We're sort of moving our way, groping forward, finding ways to supply our mobility, our connectivity, our climate control, meaning heating and cooling, and the ways we can function in modern society. And to do that as we head toward 9 billion people by mid-century or so is a really big challenge now. And that's what's caused so much attention on energy. And energy is a source of progress in so many other fields. If you have abundant energy, you have a way to turn seawater into drinking water. You have a way to do many things to foster a climb out of poverty. And that's what consumes all the panelists you're going to hear from today. And I think hopefully will consume a lot of you as you dive into your careers. And it's a privilege to be sort of running this little show. I'm going to be mainly a funnel for your questions, and I'll ask a couple of mine. Dr. Yuan Lee, directly to my left, is a Nobel Prize winner in chemistry, 1986, for work on reaction dynamics. And he is professor emeritus at UC Berkeley. He had a position at the Lawrence Berkeley Laboratory for a long time. He's the president of the International Council for Science, which is an organization trying to foster scientific basis for progress on the planet. He also, I think this is important, he's on the Academy of Sciences for the developing world. You know, we have a National Academy of Sciences. England has the Royal Society, but there is a group of scientists working to advance conditions in the countries around the globe that have the least capacity to do so efficiently right now. And it's wonderful to have him here. He's between flights from Manila in the Philippines, and you're going to Beijing tomorrow, is that correct? Oh my God. I said, where do you live these days? He says, in airplanes. So it's very, very, very special pleasure to have him here. To his left is Dr. Emil Jacobs, who is Vice President for Research and Development at Exxon Mobil's Research and Engineering Corporation, one of the many components of that great and large company. He joined Exxon in 1978, a number of decades ago, as a research engineer, and he has a degree, a PhD in chemical engineering, and he's been working both so then in the trenches of doing the basic research and also now running, sort of administering how you advance a corporation's interests by innovating in energy. On the screen is someone who's becoming a long-standing contact of mine when I explore these issues, Nate Lewis. He's a chemistry professor at Caltech. Importantly, he runs one of these innovation hubs that the administration created a couple of years ago to advance specific questions in energy that have been dogged problems. And the focus of the energy hub that Nate runs is artificial photosynthesis. Can we do what plants do, but better and faster and in a way that you can harness at a large scale. And remember, scale matters as you confront the energy questions related to having 9 billion of us seeking decent lives. It's one thing to have little bubbles of hydrogen coming from a leaf of some material in a glass, but how do you make that into a meaningful source of energy? That's the question. So we're going to just dive right in here, and I'm going to ask an initial question of these men, just as sort of a conversation starter, and we'll start with Dr. Lee. Essentially, when you get up in the morning, or when you buckle into a seat on an airplane, what is your mission? What is the thing about energy that drives you the most right now?